In this presentation, we're going to look at Gaussian elimination. This is the 2011 paper from question 10. Use Gaussian elimination to solve the following system of linear equations. First off, what I can remark upon is that we can put in a 0x here without making any changes to the equation. So essentially, we can set up this system of linear equations. We can express it as two matrices. The first part, we have the matrices, the matrix 0 of the coefficients of these equations here. 0, 2, 3, 2, 3, 1, because that's 1z, or 1 times z, and 2, 1, 3. Okay? Then we can put in the variables as a column, and we have x, y, and z, or x, y, and z. And then on this side over here, we have those values there, 2, 4, and 2. That's how we can rewrite that as a system of linear equation in matrix form. That's matrix notation even. Matrix form, yeah. So what I can do now is set up a thing called an augmented matrix that we can use to calculate a solution to this answer. And how we will write it here is 0, 2, 3, 2, 3, 1, 2, 1, 3, and we're going to put in augmented with the values from the right hand side of the equation. So that's our augmented matrix. What we're going to do is perform row operations on that to get it down to reduced row echelon form. That is to say, something like this, or as close as we can get. So with some coefficients in here that we don't know, but we get it down to reduced row echelon form like that. So that is the plan. Now let's do that. So next page, let's start this out. So I just wrote it up there in the top corner just to sort of remind myself. So here's the first iteration. 0, 2, 3, 2, 2, 3, 1, 4, and 2, 1, 3, 2. Now I'm going to give these rows names. I'm going to call this row 1, row 2, and row 3. So the next stage, I wanted to perform some elementary row operations to simplify this. What I'm going to do in the first instance is I'm going to put row 1 down at the bottom. So I'm going to give this a new name just to sort of provide a bit of clarity as to what's going on. I'm going to call it row 6, and that's just equal to row 1. Row 4 is, we're going to have it as row 2. So we're just going to put back in row 2 there. 2, 3, 1, 4. And actually, sorry, I forgot to do that. There we go. And that's row 4 and row 6 are just a rearrange, are just like rows 1 and 2 just rearranged. What I'm going to do this time now is I'm going to go row 5 equals row 3 minus row 2. So let's do values from row 3 minus row 2. Actually, do you know what? What we could do it the other way around, just to keep the values positive, we can do row 2 minus row 3. Row 2 minus row 3. That's a perfectly valid operation as well. So row 2 minus row 3, 2 minus 2, that gives us 0. 3 minus 1 gives us 2. 1 minus 3, that gives us minus 2. 4 minus 2 gives us 2. It's a great start there so far. Okay, so we can divide that by 2 as well later on, but we'll just sort of leave it for the time being. Now I'm going to sort of set up a new iteration here, and we're going to keep going the way we've done before. So row 7, I'm going to just leave alone as row 4. So the top row I'm going to leave alone for the time being. 2, 3, 2, 3. Don't need to bunch them up. 2, 3, 1, and 4. The second one, I'm going to divide this by 2 now. So row 8 equals row 5 divided by 2. So 1, 0, 1, minus 1, and 1. Finally, what we're going to do is we are going to subtract from row 6, row 5. So R9, row 9, oops, green, keep that green. Let's make that bigger. Row 9 equals R6 minus R5. So 0 minus 0 is 0. 2 minus 2, that gives us 0. 3 minus minus 5, that gives us 5. And 2 minus 2, that gives us 0. Okay. Without any loss of generality, I'm actually going to divide this down by 5. That value there. So I'm just going to update our expression so that we get a 1 here, because we're not losing anything there. So it's a 1 there. Now I'm going to divide the top row by 2 in this last stage. So it's 1, 1.5, half, and 2. 0, 1, minus 1, and 1, 0, 0, 1, 0. Okay. So, and those are that's the same. All we've done up there now is just updated R10 equals half of R7, R7 over 2. Row 11 is just row 8 again, and row 12 is row 9. Okay, this is in row echelon form now. Okay, so we're able to get a solution. You might notice that what we're going to do now is re-express that as an equation. So we're going to do that here in black. So what does that mean? X plus 1.5y plus z equal to 2. Y minus z is equal to 1. And z is equal to 0. So what does that mean? Z is equal to 0. That's great, but let's look at the other two equations. That means we can disregard that part and disregard that part. So therefore y is equal to 1. And what does this make this part here? So y is equal to 1. Let's look at the last part there. X plus 1.5 times 1 is 1.5. And that's equal to 2. Necessarily, x is equal to a half. So the answers are, let's go back here, 1.5, a half, 1, and 0. So to put it all together, x is equal to 1. It's equal to 1/2. Y was equal to 1. And z was equal to 0. Let's just double check that for a second. Yep, x is equal to half. Z is equal to 0 and y is equal to 1. Okay, does that fit with the equations? Let's try out this one here. 2 times 1/2 plus 3 times 1 plus 0. That is 1 plus 3. Yeah, 4. Let's try it out with the top one. 2y plus 3z equals 2. 2 times 1 plus 3 times 0. Yeah, that's equal to 2. So the answer is this here. X equal to half, y is equal to 1, z is equal to 0. And that ends the presentation.